Before we proceed in this session, I suggest you to watch all the videos of this session, the Java and Web Session 7, Code Management in Java 8. Although in this session the concepts are discussed by using the Java 8, but all the concepts are supported by Java 9. The concept of modularity in Java 9 is actually an increment on the previous concepts. So I suggest you first watch all the videos of this session and then start learning about modularity in Java 9. The link of the session 7 of Java and Web is given in the video description below. Namaste everyone, I am Gyan and you are watching the session 8 of Java and Web, Modular Programming in Java 9. Why Java introduced modules? In this video we will figure out all the problems which the Java developers were facing before the Java 9. Module is a new construct in Java from Java 9 onwards, similar to the jar files. Just like the jar files, a module can contain any number of Java packages. We know that the Java packages contain classes and interfaces. In the previous video of this session, we learned about the purpose of the modules in general purpose programming. In general and in any programming language. If the idea of module construct in Java is simply to break the code into small encapsulated units, then we could do it before Java 9. Before the module construct in Java 9, we could break the code in various packages, we could break the packages into various classes, we could break the classes into various private and public members. We can also collect various packages in jar files. So the question is, what is special in module system of Java 9? There are three main reasons to introduce module concept in Java 9. First one is to provide better encapsulation. In the earlier versions of Java, public was too much public. How the public was too much public, we will see in a while. There was deployment problem in earlier versions of Java. All the runtime classes in earlier versions of Java were in the single jar file, and name of that jar file is rt.jar. rt.jar was very big in size, more than 60 MB. Let's see the meaning of these 3 points one by one. Public was too much public. Let's see what it means. We have a jar file add point coordinates.jar. The jar file contains two packages, outside and internal. The package outside contains a class point.class. The Java code corresponding to point.class is given here. The package statement of point.class is package outside, so the point.class is inside the package outside. The point.class also imports the class point2d from the package internal. The class point has a method add. Inside the method add, we are creating an object of type point2d. Finally, we are calling the method add by using an object of point2d whose address is stored into the reference variable p. And this is the Java code corresponding to the class point2d.class. The package statement of point2d.class is package internal, and the point2d.class has two integer variables, the variable x and the variable y. Variable x contains the value 2 and the variable y contains the value 3. The method add of the class point2d adds these two variables and returns the sum to the caller. So here p.add will return 5. And whatever the value is returned by the method add of the class 2d will be returned by the method add of the class point. Users of this jar file are supposed to use the class point, not the class point2d. Here the user 1 created a class use and imported the class point from the package outside. Then after in the method main of the class use, the user of the jar file created an object of type point. Finally, the user of the jar file is calling the method add on an object whose address is stored into the reference variable p. But since the class point2d is also public, so no one can stop a user from using it. The class point2d is not supposed to be used by this user. But since the class point2d is also public, so this user can use the class point2d. If the class point2d was non-public, then it could not be used by the class point itself. Since the class point2d is in a different package than the class point, so if the class point2d was non-public, then it could not be used by the class point. We want the class point2d to be accessible by the class point, but we do not want the class point2d to be accessible from the outside of this jar file. The package name internal cannot stop the user from using the class point2d. This problem is called jar hell. So all the public classes inside the jar can be accessed by all the users of the jar file. This problem is called the jar hell. Now see, there is another user, the user 2. The user 2 is using the class point2d instead of the class point. The user 2 created an object of type point2d and directly calling the method add of the class point2d. Now what happens? The jar file has been updated. And instead of using the point2d, now the jar file contains the point3d. The class point inside the jar file has been updated to cope up with this updated class. Now the class point is creating an object of point3d instead of point2d. But the interface of point.class has not been changed. It's still the method add. The user of the jar file still needs to create an object of type point and call the method add of class point. So the code of user 1 has not been changed. The code of user 1 is similar to the previous one. The user 1 starts using the updated jar file without updating his code. So if the new version of jar file started working on the 3D point, then user 1 do not need to worry about it. His code will work absolutely fine. But what about user 2? User 2 still imports the class point2d from the package internal. And inside the package internal there is no class whose name is point2d. So the import statement of user 2 will throw an error. User 2 needs to update his code according to the changes in the jar file. We want the class point2d or the class point3d as public classes so that they can be accessible by the class point. But at the same time we do not want these classes accessible from outside of the jar file. Till Java 8 we did not have such feature. But the module concept in Java 9 provides this feature. Other problem in the previous versions of Java, the Java 8 or before, was deployment problem. Suppose we have three Java codes, a1.java, a2.java and usepack.java. The package statement of a2.java is package pack2 and the class defined by a2.java is the public class a2. The method print of a2.java prints pack2.a2. The package statement of a1.java is package pack1 and a1.java imports the class from the package pack2. The class contained by a1.java has the method print. The first statement in the method print is to print the string pack1.a1. In the next statement we are creating an object of type a2 and then we are calling the method print on an object whose address is stored into the reference variable a2. Then we have usepack.java. The method main of class usepack first prints the string usepack. Then we are creating an object of type a1. Finally we are calling the method print on an object whose address is stored into the reference variable a1. So how the program will execute? First it will print usepack, then it will print pack1.a1 and finally it will print pack2.a2. When we compile all these three Java files, then we will get this directory structure. Inside the directory Java 9 as our current directory, we have two package directories pack1 and pack2. Inside the package pack1 we have a class file a1.class. Inside the package pack2 we have another class file a2.class and inside the directory Java 9 we have another class file usepack.class. When we run the class file usepack, it will print the string usepack, then it will print the string pack1.a1 and finally it will print pack2.a2. If we delete the directory pack2 and run the class usepack, then it will print usepack pack1.a1. After printing pack1.a1, it cannot find the class pack2.a2. So the JVM throws no class def found error. But before throwing no class def found error, the program has executed rest of codes. In the real and big projects, such errors may be detected after few days of deployment. Because this error gets detected only after the program already started execution. In the Java 8 or earlier versions, there is no way to detect the error before the program starts execution, even if we are dealing with the jar files. Suppose the developer has to collect these two packages in a jar file and give that jar file to the user. But while collecting these two packages in a jar file, the developer forget to collect the package pack2 in the jar file. The jar file has been delivered to the user. The user of the jar file comes to know about the missing class in the jar file only after the program already has been started the execution. And for a bigger application, the user of the jar file may encounter the no class def found error after few days of deployment. It will be better if the program does not start execution if any class is missing. In the module system of Java 9, the missing classes can be detected before the execution begins. So the such deployment problem has been solved by the Java 9. The other problem with the previous versions of Java is the bigger size of rt.jar file. Before Java 9, all the API classes and interfaces are accommodated in a single jar file called rt.jar. RT means runtime. So at the runtime, this jar file gets loaded even if you want all those classes or not. In the older Java versions, does not matter what type of program I am writing, I need to load the complete rt.jar, including some legacy and deprecated classes. The size of rt.jar is more than 60 MB. In the modular system of Java 9, the Java runtime itself has been divided into modules. We need to load only that module which we require. So the problem of big rt.jar file also has been solved by the modular system of Java 9. That's all for this video, guys. Don't forget to like and share this video. Subscribe this channel if you are new and leave your valuable comments in the comment section below. Thanks for watching. See you in the next